Have you ever wondered how the universe began? Let's take a journey back in time, way back to the very beginning, when there was nothing. Yes, you heard that right. Nothing at all. No stars, no galaxies, no planets, no life. Just a singularity, a point of infinite density and temperature. This is where our story begins, with the Big Bang Theory. The Big Bang Theory, in all its grandeur, is the leading explanation among scientists about how the universe came into being. It suggests that around 13.8 billion years ago, this singularity began to expand. It was not an explosion, as the term Big Bang might suggest, but an expansion, like a balloon being blown up. As it expanded, it cooled, giving rise to the particles that make up the atoms, which in turn make up everything we see around us today. But how can we be sure this is what happened? Well, we have evidence that supports this theory. One such evidence comes from the observation of distant galaxies. Scientists have noticed that these galaxies are moving away from us, and the farther they are, the faster they're moving. This phenomenon, known as redshift, suggests that the universe is expanding, just as the Big Bang Theory predicts. Another piece of evidence is the cosmic microwave background radiation, or CMB. The CMB is a faint glow of heat left over from the Big Bang, spread out across the universe. It's like the embers of a fire still glowing long after the flames have gone out. This radiation was first detected in the mid-20th century, and its discovery was a major triumph for the Big Bang Theory. So, our universe, in all its vastness and complexity, started from a singularity, a point of infinite density and nothingness, and expanded into the cosmos we know today. It's a mind-boggling concept, isn't it? But remember, this is just the beginning of our cosmic journey. So it all started with a Big Bang, but what came next? Stay tuned to find out. Imagine a universe hot, dense, and almost uniform. This was our universe a mere second after the Big Bang. In the immediate aftermath of the Big Bang, the universe was in an extreme state. Picture it as a hot, dense soup of particles teeming with activity. Quarks, electrons, and other particles were zipping around, colliding and interacting in a chaotic dance. This was a time when the universe was so hot and dense that atoms couldn't even form. As the universe expanded, it began to cool, and with cooling came change. The chaotic soup of particles started to slow down and get organized. Quarks came together to form protons and neutrons. These, in turn, combined with electrons to form atoms, primarily hydrogen and helium. With atoms now in the mix, the universe was no longer a particle soup. Instead, it had transformed into a vast, expanding cloud of atomic gas. Over time, gravity pulled these atoms together, creating dense pockets of gas. These pockets would eventually collapse under their own gravity, igniting to form the first stars and galaxies. But the evolution of the universe doesn't stop there. It's thought that about 5 billion years ago, something mysterious happened. The universe's expansion, which had been slowing down since the Big Bang, started to speed up again. This unexpected acceleration is believed to be driven by something we call dark energy. Dark energy is a strange and elusive substance that makes up about 70% of the universe. We can't see it or touch it, but we know it's there, because we can see its effects on the universe's expansion. And then there's dark matter. It's a different kind of mysterious substance, one that doesn't emit light or interact with ordinary matter. But it has gravity, and it plays a crucial role in shaping galaxies and holding them together. The universe has come a long way since that initial bang, but how do we know all this? Well, that's a story for another scene. So, let's keep this cosmic journey going. Unraveling the mysteries of the universe is no easy task. It's like being a detective, but instead of a magnifying glass, we use telescopes. Telescopes, you see, are our eyes into the cosmos. Ground-based telescopes, despite the interference from our atmosphere, have provided us with invaluable insights. They've allowed us to observe distant galaxies, nebulae, and even the cosmic microwave background radiation, the afterglow of the Big Bang. But our vision isn't restricted to the surface of our planet. Space observatories, like the Hubble Space Telescope, have given us an unobstructed view of the universe. Free from atmospheric distortions, these observatories have captured images of celestial bodies in stunning detail. Then there's the Laser Interferometer Gravitational Wave Observatory, or LIGO for short. This amazing tool has detected the ripples in space-time caused by colossal events, like the collision of black holes. These gravitational waves provide us with a whole new way to observe and understand the cosmos. And let's not forget about the satellites and probes sent into the far reaches of our solar system. They've helped us explore our cosmic neighborhood, providing valuable data about planets, moons, and asteroids. These tools have allowed us to look back in time and unravel the history of the universe. But what does the future hold? Looking at the past is fascinating, but what about the future? What lies ahead for our universe? As we step into the realm of the unknown, we find ourselves in the company of theories that attempt to predict the fate of our universe. Take the Big Freeze, for instance. This theory suggests that as the universe continues to expand, it will eventually grow too cold and too diffuse to sustain life. The stars will burn out, galaxies will drift apart, and all will be plunged into eternal darkness. Then there's the Big Rip. This is a more dramatic end, where the universe's accelerated expansion rips galaxies, stars, and even atoms apart. Imagine, if you will, the very fabric of space-time being torn to shreds, a scenario both terrifying and awe-inspiring. And let's not forget the Big Crunch, a sort of reversal of the Big Bang. The Big Crunch theory proposes that the universe might one day stop expanding and start contracting. Galaxies would rush back together, temperatures would skyrocket, and everything would culminate in a singularity, starting another cycle of the universe. In the midst of these grand cosmic possibilities, we also turn our telescopes towards exoplanets, looking for signs of life beyond our solar system. The search for extraterrestrial life adds another layer to the excitement and mystery of our universe's future. While we may not know exactly what the future holds, one thing is certain: the universe continues to surprise and amaze us. The journey of discovery is far from over,